we have covered a wide range in today's presentation, from XBC to perovskite silicon tandems. Um, in the panel finalizing our 4-day event, we like to discuss the possible pathways from pure silicon to tandem devices. So on the panel, we have Fan Bin from GCL Perovskite, then we have Gianluca Coletti from FuturaSun, and Wei Ming Lin from Lead Micro. So please, okay, great. I can see you all. Okay, so, Gianluca, I think we don't have a lot of time, so I will go one by one. So you are not only pursuing the back contact cell, and you are already looking seriously into the tandem structure. So let's first talk about the back contact structure. So as you can see, companies are currently offering commercial module efficiencies close to 24%. So, how important is BC to the technology portfolio today, and what role do you foresee for it in the next 3 years?
Yeah, thank you, Shravan. This is an excellent question, and I reply by saying that in my daily discussion with Alessandro Barin, the CEO of FuturaSun, that's the things that he remark most of the time. Back contact, it's important. It's important because you can explain it to the most demanding customer, down to the old lady that lives down the street. It's very easy to understand. You have it there, you have the benefit, and everyone understands that. I have to say that in the past, I was not very convinced that would be required. But as I explained also today in the presentation, we are in such a variegated market, and we are so close to the technology limit, where gaining from this at least 3% of coverage that you have in a conventional front and rear contact technology. So it's about efficiency. But the other, and I have to say, for an Italian company, this is not just the cherry on the cake to have a very nice looking module. It's really the daily bread. So providing a portfolio with standard technology and a technology that is all black is key for today's market. Regarding the question, what happened in the next 3 years, I think we need to ramp up the back contact. Now it's a niche, it's available out there for a long time, but the key now is to making sure that the complexity is solved, that we have a more simple solution, and that you can ramp up and make it a more mainstream product.
And then how much you can really squeeze more from BC architecture, for the best power class and to the bulk of the products, right now we already see 24%. How much it can go up?
Well, I think it's the technology that can squeeze the most, and I would say it's at least 0.3 to 0.5% more than any other front and rear contact technology. It's not only the metal coverage in the front. We know, and it's not only about efficiency. At the end, is power. We know how much we lose in power loss when we interconnect the cell. With the back contact technology, we have one problem less in that sense, because it's all up and on the rear side, you don't have any more delimitation. We have seen also today the fact that you can you have less stress on the interconnection itself, and that's what FuturaSun is working on, to have an ideal interconnection that is suitable for back contact devices. Again, less stress, more compact cell, and therefore gain on the CTM in addition to the efficiency. So anyway, I would say few tenth of percent, 0.3, it's what you can get more than the best. The ultimate one is hard to say. As I said, we have seen many numbers. Also, the new record from Longi is very interesting. But at the end, it's what you can do in production, and at the end is on the power.
Now, I would like to come to you, Fan. GCL was a pioneer from China to build polysilicon factories, then multicrystalline. Now you are also a pioneer in perovskite development. So what are the major learnings since you started working on pilot line, I think from the last 3 years, right? So 4 years. So what were your major learnings?
Our major learning is that we have to do the things right. I mean, perovskite fits much better on glasses instead of the surface of silicon cells. And it will be much easier to exploit the potential of perovskite based on a large area glass instead of putting on the surface of textured silicon wafers. And that's why we devote ourselves to the large area monolayer. And after we get to 18% for the 2 square meter, we can move on to the tandem module. I think now it has been proved that it is the right strategy. And as we can see now, the 26.3 efficiency for the module, although the module is still not big enough, it's only 2,000 square centimeter, but it's now already much larger than the other strategy.
Since you are also working on perovskite monojunction cells, so as far as the top cell, it is always said, if you go to any conference, it is always said like perovskite is has a very high efficiency potential. It's cheap, it's abundant, it supports different methods for deposition. But what is really the devil in detail? Because you worked with it for several years, right?
Yeah. Well, and it has a bright future, but it's not so easy to exploit its potential. And we know the material is good. The device design is much simpler than silicon, but actually, when you want to make it big enough, when you bring it to a larger area, there's so much work to do. So that's why we have spent almost 2.5 years on this 1 by 2 meter line, so that we can come to this 18% efficiency. I mean, the design of the formulation, the techniques, all the techniques for the laser, and more importantly, the interfaces. And now we found that ALD is also playing a more and more important part. So we are really looking forward to have some collaboration with Dr. Li, because ALD is very important for the further development of perovskite. So it's not an easy task, and we're getting much more and more difficult in the future. So it needs the whole system to support us, and we need to collaborate with all the suppliers, with all the equipment like PVD and ALD, and maybe also sputtering and also slot die coating.
Okay, so but which one is the most difficult? There is material, then there is processing, then there is equipment, and finally you have the device structure, right? So which one you think is the most complex one you faced?
At the beginning, the most complex thing is the crystallization, and later on it's the formalization, modularization. I mean, with the laser striving. But now the most important thing for us is the interface. And the interface means the passivation of crystal, and also the passivation of electrodes, and also the contacts between buffer layer and perovskite. And that's why for now, I think the ALD is the most important thing for us for the next year.
Okay.
Yeah.
So I think now you are automatically directing me to women. So you also have a lot of experience in designing tools for not only for the very advanced one, which is the topic of today, but you also shown that you have back contact equipment. So how do you see the cost reduction for back contact cell architecture as a equipment maker? When Chinese companies entered the game, efficiencies went up, cost down. So do you believe it will be cost competitive across the board? at some point?
Yes, I think so. Basically, I think in our previous couple of years ago, I remember I commented on this equipment capex, which I think that why lead micro, for example, our ALD is currently dominating the TOPCon market. Is which I think is the method of production. It's very important. So I think that for the BC cells, these are inherited from PERC. So from TOPCon down to BC, I think these are in line. Basically, the equipment in terms of a number of new equipment is getting actually less because our equipment throughput or productivity is getting higher. This is one thing which I feel we are, include us, is working very hard on is the metallization for this BC. If we have a successful or some disruptive technologies for metallization, we can resolve this problem. Then the whole BC cells, even it's complex, but I think for the capex for the two investment should not have a significant increase compared to the current TOPCon.
Oh, okay. So, regarding the perovskite and tandem, so what are the top 3 crucial aspects you are really working on to address this this next generation technology at the production equipment level?
Yeah, as I mentioned that we are discussing with several potential customers for the pilot line solutions. From our perspective, of course, the perovskite material itself is not our specialties, but from the equipment perspective, I think that how do we manage to control the material sensitivity with our production tools, that may be the key. And then, of course, the other issue is that I really feel it's a challenge for us to work towards 1 meter by 2 meters or even larger substrate. This requires very, very high quality and very uniform films with the stabilities. So these are the challenge for the tool makers. I think if we can manage both of these aspects, I think that for the perovskites, even the tandem cells, it will be a very good future.
Okay, so, like any new technology, CapEx would also be the topic of discussion for tandem. So what is the CapEx required for tandem architectures right now? And, how low it can go in next 2 years per gigawatt base?
I would say that when we talk about the tandem cells, I think that currently the tandem can be maybe we should define it within the silicon-based tandem cells.
Yeah, silicon-based cells.
Many of these silicon cells, they have their particular or also very well known this capex, and then on addition of these silicon cells, then basically I very much agree with Dr. Fan that the perovskite itself, the cost is not very high. In terms of our ALD, if it's in the silicon-based tandem cells, I think the tin oxide, nickel oxide, or this type of buffer or encapsulation, they can be very low cost. And then provide if you have a wet chemistry, it doesn't really, based on current my estimation, you have only perhaps 20% capex increase based on current any of these silicon cells. in future. I mean, in future.
In future.
Yes,
so
I
how it
think
is now?
from the tool, you know, currently the vacuum tool, they have the PVD, they have, we work on the ALD, there is also many other things. The current pilot line is very expensive. When we put down the gigawatt scale, I think that for the tool cost is at least it will be equivalent as a PERC cells tool cost.
So then a question to all. So will basically all cells be back contact based in the end before the industry moves towards the tandem?
Maybe I take this first. I say no for two reasons. One, because I think the market will be more variegated. There will be more interest to have still the super top cone on the super heterojunction with nearly 99% bifaciality for agri-PV or for some application. And then you will have the ultimate efficiency that comes from the back contact for application that, yes, you could call it a niche application, rooftop, but it's not a niche anymore. It's still tens or maybe even 100 gigawatt when we go to a multi-terawatt industry. So I will still think that this will be different. And then, yes, for moving towards tandem, also answering your question of this morning, you don't necessarily need the back contact or something else. As Van Bien was explaining before, you can have basically any bottom device there, except for the cell-based tandem where you still want a front and rear contact one. So I do expect to have few mainstream product out there before we switch to tandem.
Yeah, I think that I'm also totally agree with the previous speakers. I think that there are still many technology routes are not explored yet. I think the BC is only one type of bottom cell which can be tandemized.
Okay. So within the tandem structures, as Van Bien approach is to do the tandem at the module level, but there are, you know, all the big companies or the top tier companies are mostly focusing on tandem at the cell level. So which approach you think would be the mainstream very soon? So, you know, anyone?
Well, I continue. I think this is a very challenging question. Basically, I love Dr. Fan's idea, this concept. It looks very reasonable, but I think that there will be in the practice there will be a lot of difficulties, technical difficulties need to be resolved, and currently we are working with other customers. They have this directly with silicon-based tandem cells. I think this result is very good. And even though on the textured surfaces, if people can overcome these problems, it would be also very nice. I think that it's challenging question. I like to see both successful.
Okay, so Gianluca, what do you think?
It's indeed, well, you can look from the technology push point of view. So which one will solve first the problem? A large area deposition on 2 square meter perovskite, or solve the issue of depositing on a textured surface. Or you can look it from the market point of view, which one is pulling most to benefit from the highest efficiency. So for example, lower LCOE that you can expect to have with tandem. I think it's the combination that of the two that will make sure that we from the technology point of view will push one or the other.
Yeah, so we also expect that both strategy can lead to some good devices. And we do have a group who is still working on the direct tandem based on silicon cells. We are still working on that, and we also hope that there will be some progress on both strategy.
Okay, so what is the ecosystem you envision for the quick progression of the tandem into the mainstream? What are the top 2 or 3 points you would like to have for this great progression?
So maybe I start first. I think the most important thing is still the efficiency. Hopefully next year we'll be able to bring 26, and in the year 2025, we hope we can get to 27 for this 1.2 by 2.4 module. And maybe in 3 to 5 years, we can see a large area module with efficiency up to 30 or even 32% efficiency, so that we don't need to compete with silicon modules directly, which will be very, very tough. And we can go to maybe the higher end of the application, and to avoid the direct competition with the silicon modules. Maybe that's the better way for us to survive first.
Maybe from my side, I do first see a big challenge in addition to the efficiency, which is the reliability. And we know there are many institutes working out there to solve that, but the ecosystem that would make a successful tandem and probably introduce it in the market as soon as possible in an ecosystem where there is some sort of collaboration. It's a new absorber. We don't know how it works out there. It will work only if there is an ideal ecosystem where industry, institute, and tool supplier sort of work together to solve that. And in addition, we don't want to see a tandem where there is only one player out there, because it will have all the problems that we have seen, like the first one that enter in N-type, the first one that enter in back contact. Either you are the best known in the market, but again, if you don't solve the issue of the stability, there will not be that. And the only way to address is if the full community, I forget to add, in addition to the tool supplier, the material supplier is really key, because it's a completely new material.
Well, I mean, what do you think?
Well, if I comment on that one, I think that from my own point of view, I think that a large difference of efficiency and reproducible efficiency will be the driving force, at least for us to even to put the efforts all in, because if we can, we all know silicon cells theoretically around 26 or a little bit above 26 is a theoretical point. Like Dr. Fan said, if we can have a tandem cells above 30% reproducible, stability things, there are fundamental theories on the stability things. But I think that from engineering point of view, there are still room perhaps to improve. But if we see the large cells, large area cells is reproducibly above 30%, I think that the whole market will be interested on that, and will push engineering to improve the stability.
So I think I'll have the final question. So when you look at these roadmaps, it almost looks like tandem age is really the next door. So what's your guess for a competitive standard and tandem rooftop or a utility scale module to see a commercial light for all of you? Can you hear me?
We do, and you have a very challenging question.
Sorry, yeah, there was some power issue. Yeah, so just any rough estimation?
I think for me also to wrap up, yes, Tandem is a big promise, is out there. Let's focus now on the technology we have and deploy it as much as possible. So front and rear contact. Let's work very hard on back contact. We need to have it there also for the opportunity it has to replace silver with copper, like we have heard. This is key. And then Tandem will come. I used to say 3 to 5 years. It all depends on solving this issue on the reliability and stability. It can easily be 5 to 7 years. But in the meantime, we will ramp up the TopCon like it is. We will ramp up the back contact, and then we focus on the back contact and the Tandem for us.
Really?
So it's I agree. It's a tough questions on that one. So I think that I think for the market to come, Tandem still will need a little bit time from our tool maker point of view. I think that we have so many years experience that currently our tool development status, if you are talking simply the encapsulation, we are there, but some critical layers, electron or hole transportation layers, and the tools, especially for large area perovskite cells, tools are not ready in such a way that it can be mass gigawatt scaled for next year. Definitely is not ready. Not, I guess, not anyone in the world is ready for that, for the two suppliers. So it will take a little while. Meanwhile, how progress can be made with the BC cells, I think that we are spending lots of time on the BC cells.
That's true. So, Fan, do you have any more positive answer?
Yeah, from our side, based on our own plan, we are starting the construction of our factory these days. Maybe next week, the construction will be started, and that's for the first 500 megawatt line. And the 500 megawatt line, it's not mainly for supplying the capacity, but it's more for us to go from 1 by 2 meters to 1.2 by 2.4 meters. It's still used to solve technology problems. And as Dr. Li said, we still need to bring the tools ready. So we have our suppliers, we have collaborators, and we are going to bring the ALD of this size ready, and maybe it can be ready by the middle of 2025. So it will still take time. Yeah, that's for our first 500 megawatt line. And if we can finish this on time by the middle of 2025, then we will be able to set up to over 1 gigawatt or 2 gigawatts. So we will carry this out step by step. And at the same time, I think we should be able to provide more panels to the demonstration plants. Next year, we are going to supply maybe like 6 megawatts to the market. And for 25, maybe we can be able to supply over 50 megawatts or even up to 100 megawatts. And that's our upper limit. And then maybe in the year 26 or 27, we can see gigawatts. That's our project.
Okay, so that means a lot to do before Tandem sees the commercial light, but then we have a lot more opportunity to explore with the single junction or the bicolor cell technologies, as Gianluca said. So I think with this remark, I would like to thank you very much for your participation. It was great. I learned a lot from three of you and also from all our presenters. So I would like to give the session to Michael to give the closing remarks.
Thank you.
Thank you.
Shravan. Oops. Cannot switch on the video. Geht mal ruhig.
We can see you.
Okay, guys, thanks a lot, Shravan. So thanks to everyone. And let me just conclude. I just wanted to share 5 slides I've actually collected over the 4 days. Actually, I think we had close to 40 presentations, but that would have taken too much time. And so I've just selected 5 slides here. The first one, if we look at today, because the tagline of our event was high efficiency solar today, tomorrow, and beyond. Today, we see commercial module efficiencies have over the last few months quite a bit. We're seeing PERC reaching what was probably quite unexpected, 21.7%, now stagnating. TOPCon, the new natural successor of PERC, can become the next standard at over 22.5% efficiency, the best commercial modules. And then we have HJT, recently even cracking the 23% level. And then we have cells or modules even now available for sale. You can buy products at 24% efficiencies. Who would have thought that this would happen a few months ago? So if we look at tomorrow, we can see, oops, oh wait, I just put, we can see on this slide that Jinko shared that the champion cell efficiency is always 1 to 2 years ahead of what we see in mass production. It's going fast. Again, also here, in a matter of 1.5 years, basically almost one percentage points that we've seen in terms of increase. And the great slide was also shown this morning by Sun. We can see here that we have a new record efficiency where we actually also see technologies merging. Gianluca was saying, okay, for tandems, you don't need necessarily back contacts, but it is there to close the gap to there. Obviously, the other technologies are making use of back contacts as well, as you see here by the new world record. Longi just showed with their HJT back contact cell, which exceeds the 27% level at 27%. And I think it's a final show to conclude, which I found pretty amazing. So we're seeing actually now by GCL in the Perovskite technology segment products that are at 27% in 2025. We're already producing in 2024, he said, end of 2023, a 2 meter by 1 meter. That's a typical rooftop size module with tandem efficiencies of 26% and are ramping up a gigawatt factory. Obviously, we'll see some megawatts, and the target is the gigawatts in 2027. Reliability, stability are obviously challenges that need to be fixed, and it might also take longer than we anticipate. But who would have thought that we're talking about gigawatts also only 2 years ago? Again, high efficiencies are the key, and we will look into that next year again. Thanks to Thanks to everyone staying with us and following us. We had over 1,000 registrants, and it's great to have you all interacting with us. We also appreciated all the many comments and contributions and answers from the audience. Thanks to everyone, in particular to the sponsors and also the team who managed that 4-day event, which was huge for us. Thanks again. I wish you everyone a few quiet days over the end of the year and a great start into a new year. We're living in challenging times in solar with overcapacities, prices dropping dramatically, and protection measures being implemented in a couple of countries, and so it's a really challenging time for the sector. And nevertheless, we're growing so quickly, having become, as Gianluca also said, the technology, the power generation technology that's there, and yeah, basically the hope for everyone, simply because it is cheaper, more versatile, and faster to deploy than any other power generation technology that we have around. So future could be bright for solar. We will report on this next year again. Thanks again to everyone, and I wish everyone a great day and an end of the year. Thanks.
Thank you. Thank you.